My dear students, today we are going to discuss Gauss Jordan method from numerical mathematics. Numerical methods, isn't it? Before we are going to proceed, please give like symbol and subscribe this video. Share it with your friends. Thank you. Okay, let us take a problem. Using the Gauss Jordan method, solve the following equations. So we are given three equations: 10x plus y plus z equal to 12, 2x plus 10y plus z equal to 13, x plus y plus 5z equal to 7. So these are the information only we are given. Let us apply Gauss Jordan technique, isn't it? What does it mean actually? Using Gauss Jordan method, we are going to get the values for x, y, z, isn't it? Okay, very easy. The very first step, interchanging the first and the last equations, and also we have to derive the equation in a matrix form. Okay, so that's why I have written a comma b is equal to, so I consider only the coefficients of first and the second and the third. But before we are going to write the matrix form, so see the very first line, interchanging the first and the last equation. Some of the problems we have to do like this, isn't it? Why? So we have to get the solutions very easily. If you keep like the same first and second row, sometimes it may be difficult to find the answer, isn't it? That's why we have to change the uh, first and second equations into replace, okay, shuffled, isn't it, according to the given informations, isn't it? Okay, now the very first equations, 115, the corresponding right hand side 7, and second 2 10 1 and 13, 10 1 1 and 12. So after blue color, okay, blue color, the we are given the system in the left hand side, the red color indicate the right hand side of the each equations, isn't it? And then yellow color, fix the pivot element row and make the other elements 0 in the pivot element of columns, isn't it? So our idea, our aim in Gauss Jordan, the leftmost, I mean the triangular matrix should become upper triangular, isn't it? Upper triangular means already you know, so only the upper side values visible, available, but the lower side all the triangular places are 0, isn't it? Okay, so how can we get the like this? I can use the operation, keep the first row as it is, there is no change, and go to the second row. So I have to put 0 in the very first place. How? I have to use this operation, technique. See the technique, r2 minus 2 into r1. So when I going to subtract the first two equations, definitely the first term, first place becomes 0. That is my wish, not wish, it is the idea from Gauss Jordan method, isn't it? So that's why very suitable number. So the second row first place 2 is available, the first row first place 1 is available. How can we, the second row become 0? I'm going to multiply 2 in row 1 and subtract with the second row. Similarly, what about the third? I'm going to multiply the first row by 10 and subtract r3 r1. Definitely the first term, first place become, both second row and the third row become 0, isn't it? So these are the suitable operations I have put, okay, that operation. Then the uh, augment matrix will become 1157, 0, 8 minus 9 minus 1, 0 minus 9 minus 49 minus 58. Okay, okay, then we move to next one. The augment matrix will become, keep 1 the first row, 1157 as it is, no change. Okay, now go to the second. The second, my aim, this place become, this should become 0, this minus 9 should become 0, already these two places 0, minus 9 should become 0. That's why I am making, or I am going to do the many more operations, okay, well, that minus 9 replaced by 0, isn't it? Okay, how? So step by step we have to do the thing. One is the first row, keep as it is. Second row, I have to apply the formula, r2 represent r2 by 8. I'm going to divide the second row, divide by 8. So this is the second row. Okay, already we know. See that second row, 0, 8, minus 9 and minus 1. So if I going to divide that particular row by 8, the row becomes 0, 1, minus 1 by 1, sorry, minus 1.125, and then the right hand side minus 0.125. And the third row keep as it is. Okay, no change. Now I'm going to do the another thing. The first row becomes R1 minus R2. So this becomes 0. In R1, this becomes 0. So that 106.125, 7.125. And the second row, no change, right as it is. What about the third row? R3 plus 9 into R1. 9 into R2, sorry. 9 into R2. So that the row becomes 0, 0, minus 59.125, minus 59.125, isn't it? So in this augment matrix, second row does not affect anything, but first row and the third row there are some changes using that or according to the operations, isn't it? Go to the last one. So first row no change, 106.125 and then 7.125. What about the second row? It is also no change. 0, 1, minus 1.125, minus 0.125. Why? So our aim, in the first row, the first place should become 0. What about other places in the second row? No need. If it is non-zero or 0 or negative, positive, whatever may be. But the thing is, first place should become 0. And what about this third row? In the third row, first place and second place should become 0. That is our wish, isn't it? See this place, the last one, this one, this place, this place. Okay, this is our favorable, our wish, isn't it? Okay, 0, 0, 1 and the last one 1. So the operation is R3 divided by minus 59.125. So after substituting this operation, the last row becomes 0, 0, 1, 1, isn't it? Okay, now the next one, the argument matrix. 101, 100, 010, 001. It means yeah, unit matrix, isn't it? And then go to the last one, right side, 111. So how can we get R1 affect by R1 minus 6.125 R3 and then R2 plus 1.125 R3, isn't it? These are the suitable operations. Then only we get the first and the second and the third. Okay, the as I said earlier, the upper triangular matrix. In Gauss Jordan, we have to convert the matrix upper as well as lower. See the upper also 0, lower also 0. Only the diagonals, okay, diagonals only we got values, isn't it? Okay, from that I can use the reverse, okay, backward calculation method. So z equal to 1, then y is equal to 1 and x is equal to 1. So all the x, y, z, they are same value, that is 1, 1, 1. Thank you, my dear friends.